Okay, we are live. Give the streams a second to warm up. We're gonna do some fun stuff. Okay. We're gonna do some fun stuff today. Today's gonna be a fun dev day. We've been doing a lot of grindy infra. Now we're gonna do some fun stuff, which is slightly different grindy infrastructure, but still, it's gonna be more fun. Now, where did I put... Hold on. Let me get the GIF from yesterday. We're gonna take a look. Let's take a look at the previous. Where is it? Open file location. Okay, so this is what we did yesterday. We got them playing the full game. I'm gonna retweet this thing out, and then what we're gonna do today is we're actually gonna pay the piper, and we're gonna make this thing actually be 1,000,000 FPS like the stream title says. And we're gonna start on the RL side. Tweet did okay. This is gonna be a good test though. Cool. I want to see what happens if I tweet this without the link, if it actually does better. Also, last thing before we start on proper dev, Twitter's so weird. Like, this is the second time this has happened where I've just made some, like, dumb, funny comment on something, and it's just completely blown up beyond, like, any of my... any of my other things, and then you can't use it for anything. Like, I can't comment underneath it like any of my other stuff. It gets no promotion whatsoever. It's so funny how that works. Internet is weird. Okay, so the plan for today, I see we've got a couple people watching this already. That's great. The plan for today is we're going to pay the piper, and I've been advertising that I will make this thing 1,000,000 FPS. Today I'm actually going to make it 1,000,000 FPS, and you're going to get to see exactly how I do that. It's going to be some algorithmic optimization, but for the most part, it's going to be making all of the tight loops in Python run natively in C without ever calling back to Python. There might be a few little hitches here and there, but I've done this process with a number of other environments, so that's why I was confident, like, claiming 1,000,000 FPS before I got it, because it's absolutely going to be 1,000,000 FPS. Now, starting on dev. First thing we're going to do, we're going to open up this setup.py and make sure we have annotate on, which is here. This tells us when we recompile stuff, this tells us exactly where it is calling back from Python to Python. So this is where you're getting all your slowdowns from here. So we're going to start with this. And we've got cmoba.pyx, which is our file. And we're also going to... There's one other thing we have to do. Python has all these checks at the top. These are your don't shoot yourself in the foot checks. This is what makes it not as painful to Devin as C, for instance. And we're basically just going to remove all the safeties, because the safeties will make it call back to Python. C division we leave as true. So now we're not checking if we like accidentally have values that are none. We're not checking array indexing errors that like Python to Python. We're not doing things being uninitialized. We're not doing any bounce checks. Okay. And we're going to recompile. And hopefully it does not crash. Sometimes there are like optimization specific things that can crash you. And then we're going to run this test performance here. Yeah, let's run test performance. Right, hold on. There's just a slightly annoying thing here that I have to do in order to make this work. And I believe I just have to do from CMOBA. Let's get our initial profile test. Really? It doesn't work. What did I mess up here? Just the imports. Whatever. Well, let's take a second to figure out why this is not working as intended. Ocean, MOBA, CMOBA. Well, we can always just put this performance test somewhere else for now, just to keep the this up for stream. So I'm just gonna copy this. MOBA perf. From puffer MOBA CMOBA. It's just from MOBA. We import puffer MOBA, and this is going to be our profile test at the start. And what do we call this? MOBA test or something? Yeah, MOBA perf. Let's see if this works. Hold on. I did something weird. Oh, yeah, it's right here. It's .moba .moba again. That's probably all it was, anyways. MOBA. See, they should run. No module. What the heck? Well, we need to get this perf test working. Let's, in the meantime, I'm going to open up something cool, just so we can get an initial look, and then I'll come back to this in a moment. And then I'll go fix this. So just so that folks have something interesting to see in the meantime. Just so you get like an interesting like overview, and I can start thinking about this in the back of my head. So if I go to the file here, pufferlib, environments, ocean, MOBA, we see that we have some HTML files in here, right? And we're going to move this CMOBA HTML into here. And now we have CMOBA here. And look what this gives you. So this file here, anywhere we have this in yellow highlight, it is calling back to Python. And anywhere that it is white, it is not calling back to Python. So for instance, this inline function here is a pure C function. No calls back to Python. This inline function here is actually calling back to Python. It looks like I didn't add a return type. So that's probably why the function signature is bad. And then I'd assume that this is also highlighted because I didn't add a return type. So when we go fix the types on this, this will no longer call back to Python, and it will be like 100 times faster. Things in init we don't really care about because they only happen once. Things like level we maybe care about, right? Here, what did we do here? Int from int, rich compare, object is true. Okay, we didn't type XP. So missing typing there. CDEF void compute observation. This doesn't look like it should have anything wrong with it. Let's see. Add trace back. Sometimes the annotation thing itself will add like spurious highlights just to function signatures. But for the most part is fine. We can see here in compute observation, it looks like I messed this up here. Let's see why. Int dy. I didn't type. Did I not type dy? Int from double. Possibly you're not allowed to use this cast syntax. I thought you were allowed to do this, though. Let me see if this was done up top. There's a different cast syntax for ccast, though I thought that they both worked. But in general, it's this type of a thing, right? Where, like, we're going to look for places where we're calling back when we don't mean to be calling back. Actually, if we're looking at this, we can see I've done a pretty good job to begin with. But, like, there's some places where definitely, like this L2 distance, it looks like this is calling back. This neutral AI maybe has a callback here. L2 distance is a really big one, it looks like. Some of the function signatures apparently are still calling back. XP is bad. Various things around here that we can potentially optimize quite a bit, right? Though I'm actually... Apparently I've gotten way better at this because for a first pass, having never opened this before, this is actually really solid. Okay, let's figure out that profile code, and we will optimize from there. It looks like there's not going to be actually too much typing stuff. As soon as we get the profile check done, I think we're probably going to only have maybe an hour's worth of type-based optimizations, and then most of it's going to have to be algorithmic. So it's pretty important where we start off for this baseline. Let me just figure out why this is not allowing me. Pufferlib environments ocean. MOBA, right? Pufferlib, environments, ocean, MOBA. Puffer. We have Puffer MOBA here, right? No module. Pufferlib environments. Oh, is it not? It's not importing the C environment. That's weird. From Pufferlib environments, ocean MOBA, C MOBA. Import environment as C environment. And that looks like it's fine to me. And what if I call it from here? What happens over here? No module CMOB. Okay. Let me just pip install. Make sure that it's actually got a up-to-date copy of everything. Python is substantially less of a pain to get built compared to PyBind with C++, for instance. but still a little bit of a pain. Just a little bit. Let me make sure that I didn't, like, take this pyx file out for some reason. I don't think I would have. That would have been weird. This is the whole setup right here for the Cython files. Pretty basic. Just call Cythonize on all the individual files. I can see I do have the CMOBA file here correctly. Okay, so this took a while to run, so I'm suspecting that maybe there was something weird there. Still cannot import this. No module. Ocean MOBA. I see the CMOBA pyx right here. I don't see the .so though. I don't see the linked file. That's weird. Right? There should be a .so. So I think that this is somehow a build error of some type. We'll rerun this this form of the build system. There are a couple like crappy tools, setup tools, that don't play nicely together. That can cause issues sometimes. As soon as we have this fixed, though, like, we'll be good for the day. You can see we get lots and lots of warnings from stuff with compilation. Some of these are fixable and just like NumPy API things. I usually do try to get the build to be pretty clean for the final version. Okay. How is this working? Does the demo work? Okay, so this actually does work. Oh. Let's do import make env creator. And then we'll just do env creator MOBA. I think we can just do this. Function reset. This is make env. Then env is going to be make env. Okay. That should work. It's just some weird binding errors. It works in the demo. Environment. What is this? Make MOBA, right? And then it returned to the environment. Huh? Hold on. There's no way that this should be running in the demo and not running here. Env module. Import ocean. Ocean dot. We'll have to figure out what's weird with the pathing later, but there's just no way. Like, this is Pufferlib environments, ocean MOBA, C MOBA, import environment. Why, how the heck does it work here? Like, this runs and I can see it render. there circular import or something? Oh, there's no underscore init. That's weird. How's there no underscore init? That's very weird. Ocean environment. From .moba. Offerlib environments, ocean MOBA, sea MOBA. This is literally bound in setup, isn't it? I'm suspecting there's just some weird shit with setup tools that's happened. Environments, ocean MOBA, sea MOBA. I'm trying to figure out why it still works in oh, I don't have chat working at all, do I? Something weird happened. I don't have chat working and I haven't had the stream window up. Okay, that's really stupid. Here we go. Yay, there are lots of people chatting and saying that there's no code. It took me 15 minutes to realize that. No wonder. Okay. Are you meaning to be sharing your screen? Yep. It would be really nice if people could tell me that, but the thing is the chat is also on the screen. This is why you don't stream people. It gives you brain damage, and then it makes it impossible to stream because you're literally too dumb to stream. That's how it works. Okay, well, sorry about that. Welcome, folks. Didn't miss very much. I will show off some cool stuff now. So, I'm having some stupid build error that I'm going to have to figure out how to fix. Let me show off the cool things now. So, this is a HTML file that is built by Python with the annotate option. And anywhere that you see yellow, your code is not running in pure C. So what we're going to do today is I'm going to first get the code built right now. I'm going to get it built up with or without some sanity options. We're going to see what FPS we're getting right now, and then we're going to get 1,000,000 FPS via optimization. That's what the plan is. This is why I shouldn't take meetings, because I forget to switch the camera back. That's another takeaway. Don't have meetings. Just write code all day. It's way better. Okay. I will tweet that the stream is fixed. Oops. There we go. Cool. Okay. Hey, Roman. Hey, Relic. Welcome. Hey, Felix. Huge fan of RL as well as LoL. Why do you think MOBAs are an interesting research topic for RL? Have you seen OpenAI 5? It's probably the best RL result out there. I mean, MOBAs are just tremendously complicated games. But the idea for this project was like, hey, OpenAI did this, but they used 128,000 CPUs, and I don't know if this is even accurate. This is 256 P100s. I think it was up to 1,000 GPUs at some point. 900 years of training data per day is what they trained on. Actually, you know what? Let's do a fun back of the envelope calculation. Okay? So 900 years per day. So in 24 hours, divide. So this is 900 years times 365 days. 364 days, whatever it is, times 364. I don't even remember. How many days are there in a year? Times 24 hours in a day times 3,600 seconds in an hour. Okay, this is the total number. 28 billion steps of data, it looks like, right? Seconds. This is 28 billion seconds of data. Okay, and I'm going to say times 5 if we're going to sample. They actually give it to you right here, observations per second. So times 7.5. Okay, that's crazy. 200 billion steps worth of data. It's a lot, right? But that's actually... How close can we get to this? That's a lot. I don't know if I can quite match that. I can get like in the ballpark though. So 212 billion steps worth of data. First of all, they did this for, and this is per day. So how much can we do in a day? If we were able to get, the best case scenario is we get 1 million training steps per second. That's the best case scenario. So 1 million, which is 1e6, times 24 hours per day, times 3,600 seconds. Is going to be... Oh, that's not bad. We get 86 billion per day. So we're actually only like a little more than a factor of 2 off. And the other fun thing is... Wait, does this include the factor of... Oh, and then there's another factor where we're going to downsample the observations per second. So we're going to do times 1.5, I think. Yeah, so we're going to get times 1.5 because we're going to downsample the data a little bit. So yeah, we're only a factor of 2 off. So that's actually cool. If I manage to make this as high perf as my other stuff, this could literally be up there with OpenAI 5 in terms of the amount of data this thing is going to chug. But with 1 GPU instead of at least 256, and with 2 CPU cores instead of 128,000. That'd be really freaking sweet. That'd be really sweet. Okay, I do have to fix this little boring bug for a moment. And then we're going to get to perf tests. Oh, I guess it's fixed. Cool. It was literally just a stupid setup tools annoying thing. That's perfect timing. So we get print. What are we going to do about the resets on this right now, right? Currently, there's no way to reset the environment. I think we're just going to ignore it for now for our initial perf test, and then we'll do fast resets later, because that's important. Okay, MOBA perf. There we go. So it's going to run this now for 10 seconds. We're going to get a rough steps per second as a baseline. We're only at 80,000 steps per second at the moment, which is nowhere near fast enough. I want the environment itself to run at like 1,000,000. So let's see what has happened here with that. One thing that we can do is we can enable profiling, actually. I forgot there's that option. Thanks for the explanation. What do you get out of this research in and except for only gaming? Can you transfer to other? Games are just a really good test bed for things in general. Like, what we care about is we care that this is a complex and cognitively interesting problem, and that it's really efficient to simulate. Reinforcement learning requires a lot of experimentation, and a lot of the things that have been hindering RL from applying to other domains is that we just haven't had like hard enough problems to run it on that are also very fast. So one of the things I'm doing with Puffer, right, is making it easy to run RL on hard problems. But another thing I'm doing with Puffers, which is what you're seeing here, is I'm making a specific set of very hard problems that are incredibly fast so that you can iterate on research that much faster. I mean, just it's a whole different game when you have to be OpenAI and you have to have a 20-person engineering team to do OpenAI 5 to get like, you know, a MOBA level intelligence versus if like a guy can just make a admittedly very stripped down but still like a basic MOBA and get like half of the perf of their entire cluster for that on a small model with one GPU, that unlocks a whole new set of progress, a whole new set of stuff that you can do with RL. So that's what we're doing here. Like MOBA, MMO especially, or games at all? We use all sorts of games. Yeah, we use all sorts of games. MOBAs are really complicated, right? They're like tremendous. I mean, you've played League, right? This tremendously complicated game. If you try to introduce a MOBA to somebody who's never played one before, they're gonna be baffled that people play these things as hobbies. Like, this is way more complicated than virtually any other type of like game hobby thing that you can think of. Right? Just like the amount of time it takes to even learn the ropes on one of these games, people forget when they've been playing them for 10 years, but you need to spend like multiple hundred hours to have any idea what the hell you're doing in one of these. And MMOs are a little bit of a different axis, right? There's not as much like complexity coming from different combinations of opponents and stuff, but MMOs are cool because they're persistent. So like you can run the same environment for a really long time and it can change over time. And they also have a lot more players in them, so it's more like the real world in that sense. So there are two genres that I think are both very useful for research. There's other stuff you can do as well. They're just two that come to mind. Platinum 4 hard stuck. Man, I played League for a very short amount of time and I was stuck in bronze. All right, so I'm bad. Only thing I've ever been good at is MMOs. I've been, you know, like top 1% or whatever. Games like Civ 6. So, problem with stuff like Civ 6, right? You can do it. there are a lot more infrastructure and engineering challenges associated with something like that, just from a game design perspective. And also, it's like a very real world context dependent game. So if you have an agent that's learning to play that game from scratch without the context of without context from the real world, it's a much harder thing to do from scratch. Like I could boot up League, I could boot up Dota, I could boot up like RuneScape in Japanese, which I don't read, right? And I could figure stuff out a little bit. If I booted up Civ in like Japanese, I'd have no idea what the hell I was doing. So that's like a good litmus test, right? Like if you were to just boot up the game in Japanese, like would you have any idea what you were doing? If not, then it's probably not great for RL. Okay, Python. So, but isn't the real world context the interesting area? Not really. Um, that's like prior knowledge, right? It's interesting in a different way. The real world context is what you would get from language models, for instance, but the decision making and the reasoning behind it you don't get. That's what you can do with RL. And as a practical matter, like doing this RL stuff is really hard, but it doesn't require that I have $1 billion cluster, right? It requires that I have a $30,000 cluster, which is still a lot, but much more reasonable. Um, so yeah, RL is this area where like there's this whole other side of learning that is not being actively explored, and you can actually do it with pretty modest resources. But to get decisions I can apply in the real world, RL is used in the real world. There are a bunch of applications of reinforcement learning where language models make absolutely no sense, where reinforcement learning just works. It's used in traffic control. It's used in like routing Uber drivers or Lyft drivers, I believe it is. It's used in like data center power optimization, lots of things where there's like a hard decision making problem that doesn't cleanly map onto vision or text. There are lots of them. And mind you, there are applications of RL, and RL has had like a tiny, tiny drop of the amount of investment and interest that language models have had. So there's a huge amount of promise coupled with like we can actually do stuff with this, right? We don't need giant clusters to do this. We can just do it. Let's rerun this thing. Their MOBA. I think I need to get the C profile code, don't I? Yeah, this thing. So we do, this is going to be test performance, right? MOBA actions. Okay, I think this works. Test performance 10 stats.profile. I just want to get a sense of like where all the time is going in these functions. Hi Joseph, how are you? Seeing you after a year or so. Can we get some tutorials on making your end faster like this MOBA? Does Pufferlib provide built-in features to make training fast without jacks? Yes, so this is a relatively new area. The high perf engineering, sim engineering stuff is the way that I've come up with of doing this is something new in the last few months. I have this project, one other project that isn't announced yet that I'm finishing up, and then like the snake project, the grid project, and a few other smaller ones. There will be a very nice summary blog post on this when I'm done, and some good, probably a good video as well. So there's going to be content on that, but it's a lot of work. I mean, this is a huge amount of work to finish up, and I want to make sure that I can really give you a good summary of how to do all of this before I post something like that. Though that said, if you want to get started on stuff now, like 90% of what you will need is in the snake environment. And the snake environment is like a 450 line of code standalone demo. It's dead simple code, and it runs at 14 million steps per second. Single thread, it trains at over 1 million steps per second. So that's the thing to do at the moment. So we have very weird distribution of timings here. So we've got 10 seconds worth of calls, but most of them are... the top time is nowhere near 10. Fill observations is about 10%. Records get attribute is 7%. Where the heck is the rest of the time going? If it's only 3.8 in moba.py step, cumulative time is 9.8. Okay, so moba step is actually most of the time. Fill observations. Oh, okay, I see. So the fill observations is a cumulative of 40% of that time. Get attribute is another second. We've got view. Okay, so there are a lot of methods here that are like weird. Yeah, there are a lot of weird methods here that are being slow, and we have to figure out what the heck is going on with this. Fine. So let's just start on this. I'm going to actually just do this. Oops. Okay. Oh, I forgot to answer the other part of your question. Does Pufferlib have built-in features to make training fast? Puffer has built-in... The vectorization in Puffer means that if your environment is fast, you're not going to get capped by vectorization. So like with other stuff, even if your environment is fast, other things on the stack are going to make it slow. With Puffer, if your environment is fast, then it's just fast. So that's the thing that Puffer provides for you. Like a lot of the work on Puffer was to make it so that fast EMs are useful in the first place. You still have to make them fast. That's what the stuff I'm working on now is, like simple ways of making really fast sims. Two people on Twitch, that's cool to see. Twitch usually has a tough time for promoting like new streams. That's awesome. Welcome, folks. Oops, where are we? CD Pufferlib, environments, ocean, MOBA. Okay, so what is this? If we look in step, thank you very much for pointing out the demo SnakeEmp. Can I please get the repo link? Awaiting the blog poster series. Yeah, a lot of this stuff is based on engagement, frankly, because like I will make whatever format of content people will actually look at, right? So like I'm going to do a test video, and like cuz people really liked my thesis defense. So I'm going to do a test video on Puffer 1.0. If people like that, I will make more. If people don't like go and watch that, then I will spend my time on other forms of content, right? Let me get you the link. It's just Puffer. Oops. So look, if you just go into Puffer here, there's the snake env is in the dev branch, I believe. So look, dev branch, pufferlib, environments. Ocean is first party. So Ocean has our first party environments, and you've got all these environments to play with. There's also an ini-config branch, which I'm merging into this soon, which has the MOBA and a bunch of refactor stuff. That's really nice, but it's a little less stable so far. Can I put this into the chat? People must watch it then. Yeah, I hope so. I mean, the thesis defense was awesome. Like, if I can get more, if people are actually going to have this level of engagement with the longer form stuff that I make, because this is like making something like this is very high effort, right? Like this thesis defense, in addition to it being obviously like something I've been working on for years, just preparing the talk took a few weeks of work, right? That's a lot of time investment. It's done amazing as a result, but like if I'm going to put like a week of work into a video and have it get like 1,000 views, then like I'd rather be deving useful tools for people in that time, right? So that's just the main thing. But yeah, this has been awesome. 120. This thing hit 120K, that's great. Starring the Puffer repo helps out a bunch. Promoting the stuff on Twitter helps out a bunch. But yeah, that's generally where I'm at. Uh-oh, stream's not frozen, is it? I think just my preview is frozen. I think we're okay. It says 0 drop frames. What is this fill observations? Oh. Yeah, okay, so it looks like we have a bunch of slow stuff in Python land. Yeah, like all this Python stuff is really slow. That's funny. So I think for this MOBA, we're just gonna do everything. We're gonna just do everything in Sealand, right? So I think we're just gonna we're gonna just straight up comment this. Thanks for pointing out where the env is. Do my best in promoting. Many people I know that use Jax because there's no other way. Basically, we were fed up with they're fed up with it. Yeah, that's the thing. And I made this. I don't know. Did you see the post that I made on Jax? I made a really obnoxious, rambly post that blew up. I made this like, where is it? I don't know. I do a bunch of things on here, but here, there's this really obnoxious article. Where is it? It's on my timeline or on my articles. So this thing got 145K views, right? This is like one of my better performing posts. And it's got this total bait title. And I talk about how like people are like, oh yeah, now we need Jax and Rust and stuff in order to make fast M's. And we very obviously don't. You know, I can just write 200 lines of Python and it's faster than anything that anybody's writing with much fancier and harder to use stacks. And it's also not limiting you to a domain specific language like Jax. So yeah, it's not even the case that this stuff is incredibly difficult necessarily. It's just nobody's bothered to actually take a hard look at the infra in RL and really put the time in. There are really no incentives in academia to do the type of work I'm doing now. Like, I had a lot of freedom in my PhD, and I still probably wouldn't have been able to justify doing the type of work I'm doing now in my PhD. So the incentive structures are just terrible. And basically what's happened in the last couple months with Puffer is as soon as I actually started taking this stuff seriously and spending all of my time on it, like, it's just rocketed to the moon, and Puffer's gotten 600 some odd stars, and like people are using it and people are having a good time with it, and like, people are watching the streams, and it's just going to get better from here, and it's going to get better very, very fast. What game are you doing now? We're doing this thing. I'll show you. Where's it? And then I should do a little bit of optimization. So we've got a, I'm not going to say full scale, but a pretty, complicated MOBA simulator like League of Legends or Dota. And we're making this thing run at 1,000,000 frames per second. That is the goal for today. Right now it runs at 80,000 steps per second. By the end of today, we're going to get it to be 1,000,000 steps per second with maybe a few small cheats. And then after that, we're going to start binding it to the reinforcement learning side and start training it at 1,000,000 steps per second. That's the goal. Okay, so just from deleting this fill observations, which will be fast in C. Let's see how much better this is. Can people run this at home? Absolutely. All of my stuff is open source. It's in the dev branch right now. It's in like a off branch of dev at the moment. It's going to get merged to dev soon. But all of my current work is in this ini-config branch. It'll get merged to dev soon. If you use it, please star the repo on your way in. It helps me out a ton. All of the simulators, I've been doing a bunch of different simulators on stream lately, and they're all inside of Ocean, which is Puffer's first-party environments. So you have MOBA, Grid, Snake, all sorts of different environments. There'll be some more docs here soon. And you can use them, you can play with them, you can ask about them over here. And they're all free and open source. Thank you. Helps me out a ton. I mean, I've said this several times on stream, right? My goal, like, Puffer is technically a company, but really my goal with it is just, like, if this thing gets large enough that companies start using it and I can get a little bit of revenue from companies using Puffer, like support contracts or whatever, then my hope is I can, like, buy a bigger cluster and support more open source stuff around Puffer with it and put together some bug bounties and stuff on that. That's, like, the short-term goal with Puffer, and that's why I've been promoting, like, the Twitter and the repo so much, is because that helps a lot with other companies seeing it. This needs to have a place in good conference, so RL Infotrack. Yeah, here's the thing. It got rejected from NeurIPS last year. It got rejected from RLC this year, both with bullshit reasons. This is my absolute best work. I've gotten way worse papers in. Nobody cares about RL Infra. And this is why it's all broken. The incentives are terrible. You can do your absolute best work as somebody who spent 7 years, and you can just get multiple rejects on conferences. Like, there's literally no incentive to do any of this. That's the reason that none of it's happened. And yeah, like, it would be nice to be able to present this at a conference, and I did resubmit it to NeurIPS this year. But if it doesn't get in there, I'm just not submitting more papers. I'm done. I'm out of the academic game. I'm actually building stuff, right? Like, I'm not wasting my time on that anymore. And there's no way around it. I spent 7 years trying to fix RL from the inside of academia, okay? Like, look, I'll show you something that I did. Datasets and benchmarks track. Okay, this year, there's a very important language change to this. Open source libraries and tools that enable or accelerate ML research. And it's actually stated a second time. Open source libraries and tools that enable or accelerate ML research. So this exact language, I wrote an open letter on this. I had to promote the open letter a whole bunch. I circulated this. I got this to last year's DNB chairs. I went through a big chain of emails with the new D&B chairs to eventually get this integrated into this year's call. Like, it was a bunch of work. So I managed to get like this one tiny thing for academia. But like, the thing is, like, what's the return on investment for this? Because like, the reviewers can just completely ignore this direction, and they absolutely will, right? Like, this does not guarantee that people are not going to just reject your paper because they don't like libraries and tools and they fundamentally don't respect your work. Like, they're going to do that anyways. It helps, but it's still bullshit. So like, I've wasted enough of my time on the bullshit academic game, and now like, I'm building stuff for academia, but I'm no longer doing it through conferences, publication, and the like. I'm just building tons of cool stuff, really, really high performance, really heavy engineering focus, and I'm making it all available for free. And like, all I ask is that people, like, if you like my stuff, is that you help me promote it a little bit so that I can like continue to build this out and hopefully, hopefully make this a thing where, yeah, I would like to have an income of over $0. That would be nice. But also, like, I would like to be able to fund a little RL lab for people who actually care about this stuff and have like some open source bounties and stuff like that and a bigger cluster. Like, that's the type of thing that I'm trying to build here. Okay, so we just went up to 109,000 steps per second with profiling on, with that garbage function deleted. We're going to have to add it back in C, but it's not going to add any overhead in C, or any noticeable overhead. Do I need to sort this by cumulative time? This is really weird how long the tail is on this, because I have 9 seconds here, or is it total time? I have 6.6 seconds, and then the next thing is 0.4 seconds. So like, this is not being timed properly if that's the case. When did you start on Pufferlib and what made you I started as a side project like a year and a half ago. I was doing my PhD then, so I didn't like, I had a PhD to do, so I just kind of like started doing some tools and stuff on the side. And it sort of became obvious, like, last summer I didn't take MIT funding so that I could work on Puffer full time, and it became obvious, like, RL fundamentally just was not going to work without the stuff I was building for Puffer. So I didn't get to spend too much time on it during the last year of my PhD properly because I had PhD stuff. But, I sort of made the plan that, okay, once I graduate, I'm going to do this full time. I'm going to invest a year. That's what I've said. I'm going to spend a year on this. I'm going to see where it goes. And if I actually have, if this is going somewhere after a year, like clearly going somewhere after a year, then I get to keep doing it. The last 2 months have been great. If we keep the growth trend of the last 2 months, this is set. But it's hard because there's a pretty limited audience in RL and we're already getting a large chunk of it. What's the reason of naming it Pufferlib? It's a bunch of tools and infrastructure. Like, what the heck do you call that? Right? There's nothing I can call this that's a good visual depiction of what this does. So here, have a pufferfish. It's funny, it's memeable, and you can feed it lots of libraries. Understand your fear over reviewers. Your efforts not going to waste. In a conference perspective, someone will be picking your work up. Aims right now help the community a lot in industry. It should give you an income. Yeah. I mean, I'm fine. Like, I can pay rent. That's not an issue. It's just like, I'd like to be able to scale this stuff up. And it's the thing with reviewers that made me really sad in academia was, by the end of my PhD, I figured out how to consistently publish stuff, even in like this wonky area where it's really hard to publish, right? Like, I figured out how to write papers that I could consistently publish, but I hated them. Like, I wrote papers that I considered bad in order to get them published. Anytime I wrote something that I was genuinely proud of and I thought was a good paper, a good contribution, it would get rejected. So I don't want to be doing that anymore, right? It's like, I want to be able to write the thing that I know is the good thing to write, regardless of what the reception is going to be. And like outside of conferences and stuff, there's a big enough audience for this stuff that if I just do a bunch of different good projects in and around RL, like that's going to be way, way better than publishing some random papers. Yeah, it's very sad. But like the thing is, we've done this to ourselves. Like it's the RL community doing it to ourselves, right? Like this is completely avoidable. Like if we in RL, because we're reviewing the papers, if we just like stopped rejecting essential things that we need for the field to move forward on the basis of like them not matching up with science, what we consider to be good science, like there would be an incentive structure for PhD students to do this type of work, and I wouldn't have to be doing it outside of academia because it would already be done. I know several people in RL that have done like absolutely amazing infrastructure work, got absolutely zero recognition, and they fucked off and they took high paying jobs working on language models. That's what they did. They said, screw it, I'm done with this. You know, this is ridiculous. There's no money in this. There's no recognition in this. I'm just, deving in the dark for hours and hours on end. And they went and they took high paying jobs working on language models. And that's really sad because, like, when you're working on really high quality stuff like that, there should be a way to get your work recognized, but there isn't. And I tried for many years to make a way for that to happen, and there was just no way to do it from inside of academia. So the way that I'm looking at this currently is, well, if I can just make reinforcement learning so much faster and easier to work in that you can get really awesome results way more easily, right? Then it's going to be way, way, way easier to get more people doing RL. That's what it's going to be. And I'm glad to be able to talk about this more publicly as well. Like, I didn't have a gag order or anything during my PhD, but I didn't want to put like a bunch of inflammatory takes around that would reflect badly on, MIT or my lab or anything. But now, I'm graduated. This is fully independent. These are only my own opinions, not those of my lab or anything else. And yeah, I'm very happy to be outspoken about that now. What the heck is wrong with this? Let's make this give us like the top 25 functions. Because this is bizarre. This is like a really bizarre profiling curve. Bring investor attention. Oh, investors are not the problem. If I wanted to get money for this, I can get investors. The thing is, it's way, way, way better if I can just bootstrap this, right? Revenue is way better than investment. This is very, very weird, this profile curve here. Like the fact that it just goes from... Okay, so first of all, this says that we're losing 30% of our performance inside of the Python wrapper for step, right? And then after that, clip dep invoke with casting. Clip. I don't even know where we're calling clip. Let's grab this. How do I mute the stupid sound effect on Windows from this? System sounds, mute. Okay, so what do we have here? Sorry, I missed your reply to my message. Which one? The last one? I just said that I'm not even really looking for investors in this. If I wanted to get an investment check for something around Puffer, I could. Um, I've already talked to people who have been like, somewhat interested, just in passing. It's more that I want revenue for this. I'd like this to be bootstrapped. I'd like this to have no strings attached. I don't want this to be tied to investors and shareholder obligation. I'd way prefer if I can get this thing to just bootstrap itself via revenue and self-fund cool RL lab around that, that's infinitely better. Okay, so interesting. This is this discretized at the moment? I thought this was discretized, wasn't it? Hold on. Definitely hope it does. Yeah. And it's going very well at the moment. I will say. Like this growth trend. If we keep this up, all of the problems outside of technical will solve themselves. And I'll just be able to keep working on the technical problems. Like this is what you need. How the heck is this thing spending so much time in NumPy clip? There shouldn't even be clip shouldn't even be called. Being called here, and then this is in the renderer, which we're not running the renderer, right? Yeah, we're not running the renderer. So okay, what's the report interval here? 32. That's probably way too... Yeah, that's probably way too quick, right? Whoa, I've missed a lot. Oh, did you just check on the latest environments and stuff on Twitter? Stuff is happening fast. Stuff builds fast, man. I'm telling you, as soon as like I no longer had to care about the academic side of things, stuff just happens so freaking quickly. It's not even funny. This MOBA is 1 week of work so far. Like I guess a week a weekend, 2 days, week and a half then. And I haven't even been like particularly on point either. I've been like kind of tired, kind of burnt out. Been doing a whole bunch of running that's been, making it really hard to stay focused for long work sessions, and it's still been just cranking. And we're gonna get at 1,000,000 FPS today. It's actually gonna be harder than I thought it was gonna be, but we're gonna get it today. That's the goal. The goal for today is to actually make the thing in the title true. Busy with PhD proposal, only like a month? Well, in a month, we've gotten best-in-class hyperparameter tuning working. We've made a 14 million step per second snake environment. We've made 4 different continuous control / discrete grid environments for multi-agent learning. And we've made this MOBA. So a lot happens in a month. I would like to know what the heck is calling clip. So we're up to 116,000 steps per second with profiling overhead. Something is wonky here. We're losing nearly 3 seconds out of 10 inside of the Python wrapper. What the heck is happening inside the Python wrapper, right? What the heck is happening? Catch you later. Welcome to the YouTube, folks. We're currently optimizing this thing to 1,000,000 steps per second. Looks like there's a lot of room for optimization. I just have to figure out essentially where the overhead is, because the profiling tools are not, they're not doing a great job at the moment. Does this thing ever get reset? No, it doesn't look like it. So it's interesting. The only thing here that is self.buff.rewards.fill 0. This could be it, maybe. I wonder if this is slow. Well, one thing I could do, right? Let's say, let's say I just put this cast up here. And then I just, like, comment out all the stuff that's not strictly needed, right? So I just need this step, right? And we'll see if this works. And what infos is just going to be empty. Does this reduce the overhead? Expected float got unsigned int. Really? That would actually explain something. So if that is the case, welcome bank. Does this think we're supposed to discretize? Oh, for some reason we have discretize false here. So it's calling this clipping function constantly. Do we care? We might not care. We can always clip on the, we can clip in C. If that's really going to be, if that's going to be a bottleneck, we can clip in C. So the thing that's different about this project compared to the other ones that I have to think about is, this is kind of technical, but a lot of the other environments I make have like 1,000+ agents in them. So what that means is that, like, you're making one loop through the Python for every 1,000 agent steps worth of data. There are only 10 agents in Dota, right? It's a 5v5 game. So what that means is that I have to be way, way, way more careful about the Python overhead, and I have to put even more stuff into C than I normally would. Which isn't hard. You know, you can do it. It's not hard. But you do have to, you know, actively notice and care about this stuff. So let's see if this does any good for us. We were at 116K before. Look at that. From 116 straight up to 180K. Very nice. So, okay, now we have 9.5, 9.7. Okay, at least 95% of the total time is in this step function here. And I can't tell if we're getting, I don't think we're getting Python functions in here. We need to get the Python function perf, because all these are tiny, right? Test performance, there's a little bit of call overhead, yeah. NumPy from file. What? I guess there's some weird shenanigans happening. Oh, this is just a startup overhead. That's no big deal. Wait, are we actually timing this right then? If this is the... Wait, are we timing this right? We might not be. Yeah, we're not timing this perfect. We're losing out on some time that we shouldn't be. So what we should be doing is we put this tick here. We do... This goes here. Action cache is going to be 1024. This is just random noise. Don't worry about it. And then we adjust the signature of this to be env actions timeout. And then okay, so now we have the env reset not being tracked in this, and we can do test performance of env actions 10. So just by fixing our measuring, essentially. That should cut out a bunch of garbage that we don't want to look at. Yeah, there you go. So now we no longer have a whole bunch of trash to look at in here. And the fact that there are only a few lines means that this is all that's running. All that's running that's substantial. So we've got a small amount of call overhead. It looks like we've got this as type is actually, this cast takes up a little bit of time. But these are neither of these are significant. So at this point, we have to actually get the profiling to get into the Python code. And we need to figure out like where in the Python code stuff is being, where stuff is being jank, essentially. So C profile. Good. There's something you have to do to get these things to work. Profile is true. Slight overhead. Yeah. C MOBA. Oops. X. Ah, we have a profile override to true here. This should be true. Now, there is going to be call overhead with this. Oh, I didn't get the time on this, did I? Okay, still 180K. So we're already more than double what we started. And we don't have to get 1 million FPS on this machine either. This machine is like half the speed of the actual server. So we only need to get like another factor of maybe 2 or 3 out of this, and we'll be good. Okay, perfect. So now that this is compiled, we can see the one problem with doing it this way is you can see that the SPS is completely crashed. This is because of the profiling overhead of running all this data collection. So this data is not always 100% accurate, because when you have more overhead from profiling than the actual thing that's actually taking to run it, you can see how that would make it hard, right? But I think that the relative compute time should still be more or less correct here. So it's actually a pretty darn nice curve to start with. It's a pretty nice profiling curve. I'm going to get the HTML file just so I make sure that I have the latest one. And we're going to refresh. Where is it? We're going to refresh this file. Let me make sure it refreshed. Yeah, so now this returns an int. Perfect. This still is not typed correctly, but whatever. So I'm going to make sure that you can see this on the stream. Okay. So now all we have to do is we go through all of these and we see if any of this is caused by calls back to Python versus algorithmic overhead versus me having designed stuff stupid. So the first function I see is scan AOE. That I believe is algorithmic overhead. I think we're going to have to do some caching there. I think that that's probably a very efficient function that just needs to be cached. So as you can see, this function runs in pure C. It does do a number of checks that I could potentially improve upon. Yeah, it does do a number of checks that I could potentially improve upon. I could save some time that way. But I think that most likely is going to be that this function can't get called every single frame. Right now, it's getting called every frame on every creep. So, like, everybody's constantly rescanning for targets. And I think that if you you just run this thing at a more reasonable interval, that'll probably be fine. Though there's going to have to be a little caching for that, maybe. We have step function itself. The step function should be a very large function. And we do have a callback to Python right here. Welcome, Fruit Punch Samurai. Welcome. Welcome, EXX. We are optimizing the hell out of this code. We're currently at 180,000 is the best that I've seen so far. And the goal is 500,000 on this machine at minimum, which will be over 1 million on the box. Missed a few streams? Yeah. Well, I'll show, since there's some people, I'll show the GIF while I look at, I'll pull the GIF up while I continue looking at this. That's the latest version. It plays full games now. So this call here is calling back to Python. This NumPy actions is not typed. It probably should be typed. This is a very slow callback to Python, which is weird. Use Q is a beant. Weird. We will fix that. And then these return values are also because step doesn't have a return type. Okay, cool. Yeah, this is what I did. This is how we ended the stream yesterday. We're basically just reusing the creep AI on the heroes, and then we have 3 heroes assigned to safe lane, 1 assigned to mid, and 1 assigned to off lane or hard lane. And they will play full games. So let's just fix step real quick just to see if that does anything. So it's a little awkward because this is a deft function, which is supposed to be Python API, but I think we'll just expose this with cpdef, which allows us to add a little bit of extra typing information, and then we can do mp.ndarray, or it should be cnp.ndarray. So we add typing information to this, and I think that this will still potentially trigger a callback to Python. The only one. Yeah, only one. And then this one is the big one that breaks the loop right here, is this int continuous whatever greater than 0. greater than 0.5. That's kind of weird the way I structured this, isn't it? I mean, we're not using this at the moment whatsoever, so I'm just going to comment this. And then, like, to-do breaks Python. We're not using this at the moment anyways. And I think this is the only thing that calls back to Python, so yeah. Okay, and then we should have a new HTML file. We'll move it. We'll refresh. Perfect. So this is now no longer yellow. And this is still, okay, as I expected, this is still yellow, but this is once per frame. This is not in a loop. No big deal. Potentially some method call optimizations we can make. I know how to do that separately. No big deal. A lot of these method calls are not positive, actually. I think this is the profile overhead, actually. Like, the reason a lot of these have this yellow is because I'm running profiling. We can check on that, though. Okay, so now that we have this running, we can do our profiling again. Not expecting a huge difference. Maybe something, though. Step is... Okay, step is still at the same... roughly the same pace. It's saying a quarter of the time is being spent inside the step function and not inside any of the other functions that are being profiled. That's kind of weird. I mean, I guess we do have like loops like this, but this is a %6. This is like not called very often, the %600. We have some method calls. Oh, I know. If the method calls themselves are going back to Python, maybe. But wait, if the method calls were going back to Python, they should show up in yellow here. I think they should show up in yellow. I could be wrong. Let me find something that definitely calls back to Python. Okay, so nearest scan target, for instance, calls back to Python. And I know that nearest scan target is called from like Tower AI or Creep AI or something. But it's not showing up here. So probably it's just the method calls are actually going back to Python. And we'll have to figure that out. That's my guess. Let's focus then on some of the lower level ones. So we've got compute observations. That's a pretty performance critical thing. And we can see that I have some typing problems, it looks like. R is typed as an int, and dy is typed as an int. Is this cast not valid? I thought that this cast was valid. See, it's not... Why is this valid? This move to function here, this is not triggering a callback to Python. This is parsing as a valid cast. Why is the other one not parsing as a valid cast? R is an int. Int of player. Is player not defined? I don't see play. Oh, wait, here it is. Player. Entity start player. Y is equal to player get Y. Well, this doesn't need to be player dot Y, right? This can just be Y because I computed it up here, though I don't know why it would make a difference. Let's see. This is a very performance critical function though. Int y. Wait, what? How the heck am I doing this? dy in... Okay, I'm just doing this in a very stupid way, I think. Because... And then we have y and x, I guess. Yeah. I think I'm just doing this in a very stupid way. This is absolutely a performance critical function, by the way. This is called on every hero on every frame, and it does a scan, and it fills in a bunch of data. It copies a bunch of data. So this is very performance critical. So here, we got to go slow with this. We've got float y, float x. Do we use y and x anywhere? No, we do not. So we do not need these. We do want y and x, maybe. How do I do it in scan AoE? I think that this is a more recent piece of code. I did actually do dy and dx here. It's not terrible. I think I could do this potentially. But I think that actually both of these are going to be more efficient if instead of computing the delta offset like this, I just use y and x directly. So if y is in a range of let's use r for this maybe, because y is going to be an int now. We're going to do int y. Yeah, int r, c, int y, and x. So we're going to have x, y, r, and c. And then we're going to do... y is going to be int of player.y. X is going to be int player.x. You have to talk about ints a lot when you're talking about MOBAs. Can't have your creeps inting. This is going to be y minus vision range, y plus vision range, right? We don't need this garbage math in here. And then this is going to be c in range of x minus vision range, x plus vision range plus 1. Now, we get the target PID. If it's -1, we continue. We get the target. We have to figure this out, but we're not doing that right now because it's going to be really boring to watch. And then I think that's all of our typing problems solved. Do we use agent IDX anywhere? We don't use agent IDX. Let's get rid of this garbage. We do use IDX, it looks like. Do we use PID? We do use PID. And we use target PID. And target up. Okay, so let me make sure this makes sense. The way the compute observation function works is we're going to go through self.num agents, which should be 10. This is hard-coded, these numbers, but we're setting the observed values to -1 to start with. This is just clearing a buffer. This is a sanity check. It's kind of slow, but we'll improve that later. I'm looking for low-hanging fruit first. We get the player that we're currently computing the observations for. The main set of observations is going to be a slice into the grid that is just going to tell you the obstructions around you, essentially. This is like a map that gives you some basic high-level information about what is around you. And then the main meat of this function right here is a much more detailed map that tells you about any agents that are nearby you. So you're going to go through all your surrounding tiles, and you're going to look for potential agents, creeps, anything like that. And then you're going to extract a bunch of additional information about these, up to 10. So you're going to extract up to 10 agents worth of information around you. And this probably as a to-do, we should do this like sort by distance. It should probably be the 10 nearest agents to you. And frankly, we can probably repurpose the scan AoE function, because the scan AoE function is perfect for this. It just gives you all the nearby targets. For now, we're going to leave it this way, though, and we're going to see if we actually improved anything. Doesn't look like I broke anything. If I didn't break anything, then we should have a new HTML file here, which we do. We'll move over the HTML file, we'll refresh this, and now our compute observation function runs in pure C. Isn't that nice? So it basically looks like Python. It's almost identical to Python code that you would write, but this is pure native C speed for this performance critical function. I don't know if it's going to give us any benefit just yet. We'll see. Ooh, it looks like I potentially introduced a bug in the process. Differing dimensions extends 11.0. That's gross. Runtime bugs are gross. Because I forgot to do this R and C. Hold on. Excuse me. I just forgot to update some variable names. This is supposed to be, I renamed R and C, so this is now Y, this is X. This is Y, and this is X. And that should be fine. Okay. Playing mute toggle game here. Refreshes. We copy the CMOBA thing over. We make sure we've got our new source, which we do. We run our performance test. Runs for 10 seconds, roughly. And there we go. So this is indeed much faster. We saved, I think, about a third of the compute that was just being thrown away on that function from periodically calling back to Python. This used to be a full second, I believe. So we shaved off a little bit there. Really, though, I'm looking for bigger performance improvements than this. I see. It's a little hard to tell, though, because this profiler adds so much overhead. Like, C profile adds, this should run 180,000 at least steps per second. So with 90% overhead, it's sometimes hard to tell which of these timings to trust and which not. Let's see some things that if we have some basic free wins here. Creep AI is kind of slow. All this stuff doesn't matter. Entity star get player ob get entity. What the heck? Why is this running? I'm pretty sure that's just the profiling overhead. I don't see how it would be possible for this thing to be this slow, because this is literally just a lookup. I might want to try... I'm going to do an experiment. So this is 0.7 seconds right now, which is not insubstantial, and I have a lot of functions like this. So what if I inline this, right? cdef inline entity star. Does this do anything? This should tell the compiler to never treat this as a separate function. It should always try to just put this operation directly into the code. So like this is a one-line function. Instead of calling this function everywhere and adding the overhead of a call, it should just run that one line of code directly wherever. It's kind of like not having a function and just copy pasting it everywhere. Doesn't always do anything. And in this case, yeah, so this didn't do anything. I'm not going to do it if it doesn't have the clear benefit. I suspect that this is just function like profiling overhead, because this function is called very, very often. You can see the number of calls, and if there's just a little bit of profiling overhead associated with this, then this would be what you would get out of it. Very obnoxious though that this is like happens with your profiling code, right? Is there like a decorator? No profile decorator. Is there, can you use a PyX decorator or something? Python.profile. I think this is the Python API. I don't think there's a good way to do that. Oh wait, here it is. Import Python at python.profile. Perfect. Let's see what happens with this, because we might be able to get some more reasonable results by ignoring these little tiny functions. So import Python entity. We're gonna do at on dot profile false. I want to see if it doesn't show up in my profile anymore, because it would be really nice if I could just ignore these short functions, because they make it really hard to profile when you have this much overhead. Like anytime I'm timing a function that's calling this thing a bunch of times, I'm adding like a Python callback or a profile callback every time. And it makes it really hard to get consistent results. Does this show up? Or does it respect my override? It looks like it respects my my override here. The steps per second went up by a little bit. And yeah. Okay. So it omitted this function from profiling. And wow, that actually made a huge difference, didn't it? Like the whole profile table changed just from that. I think it's going to be worth adding this to all of the small little functions, because like it doesn't, not profiling the function doesn't mean we're not profiling that code. It just means that we're not separately profiling that code. So like here, we're profiling this code implicitly anytime we're calling this function from somewhere else. But the thing is, like, if I look at the table, where is it? If I look at the Python op table, I see that all these functions are already optimized. Like, the returns of all these functions are already pure C anyways. And they're already properly typed. So there's no reason to go further than that with it. And actually, if I move this, can I see the profile line taking effect here? Oh, look how cool this is. You add this decorator, and now this function shows properly as being in pure C, because if you look here, this is just a raw function call, whereas this one, it has all this traceback stuff that is being used for the profiler. So this is actually perfect, because it's being annotated, but it's not being profiled, right? If I do like x equals 2 here, what happens? I want to make sure that we actually have this working as intended, because it's very, very important. Okay, we recompile. And then we rerun. I want to make absolutely sure that the annotation is going to pick up stuff even that's not in profile blocks. I'm very confident that this is the case, but this would screw everything else up otherwise. Okay, so we ran the profiler. We moved this file. Ooh, that's jank. Pi VX. Oh, wait, I think it could just be the compiler optimizing it out, right? Let me try one other thing, and then we'll stop with this line of inquiry, because the compiler is going to be tricky. But this is suspicious. I'm going to try to trick the compiler here. So what we're going to do is for I in range, let's do like a self variable, something that's dynamic. And we're going to go like PID plus equals I. So let's see if this can trick the compiler. Obviously, we can't run this code now because I've just broken the logic. But you don't need to run the code for annotation purposes. It's compile time. Okay, and perfect. So this is exactly what I was looking for. You see? So right here, this function, it has profiling disabled, but annotation is on. So if I add something that's going to make the compiler call back to Python, even though I'm not profiling it, I can actually see that it's calling back to Python here. And importantly, if I remove this, like we saw before, this is going to turn white, telling us that this is a pure C call. So that's exactly what we want. And then we'll be able to do our inline shenanigans, and we'll be able to run that experiment correctly as well. We're going to take all of these shitty little functions, and these are all going to be profile off. Don't need to profile any of these like stupid little functions. They will all be profiled purely. We're not even going to inline them for now. We'll do the inline experiment 100% separate. Boom. Okay. None of these are now profiled. And I think that's, yeah, that should be all of the annoying little functions. We build, and we should actually, just by that, we should be getting something that's at least within a factor of the actual performance of our environment despite the profiling overhead, because most of the profiling overhead comes from these small little functions that are just getting like chucked in with the rest of the profiler. OpenPerf.py. This will run for 10 seconds. So much better. So this is now 3 times faster than before, which is still like a quarter of the speed of our actual environment. But this, at least now we have some hope of being able to tell relatively what's important and what isn't, right? So let's see. Move function, update status, update cooldowns. Lots of these little functions. Let's see. Are those functions bad? Hold on. Let's run this, redo. Perfect. Look at that. Pure C. Let's look for like update status and cooldowns. So this is an obnoxious amount of time to be spending in these functions, right? Look at the number of calls here. This gets called on every entity at every step. So even though these functions are pretty highly optimized, like these are just straight up conditionals, they're taking a lot of overhead just because of the amount of times they're getting called. That's actually kind of useful because it tells us that any function that's getting called every step, every entity, is going to add like 0.2, 0.3 seconds, right? So like these neutral AI functions and stuff, 0.3 of this is just, or I think 0.15 of this is just call overhead. That gives you a scale of like how efficient we're talking here. I want to take these out of the profiling though as well, because these are like so minor. And again, we're trying to figure out where we're losing perf on step. And this isn't telling us where we're losing perf on step. So step is definitely really slow, and we're not able to tell why at the moment because of this other profiling overhead. A nice thing to note about the stuff that I'm doing right here, if you think about it, I would be doing this exact type of profiling in C or C++ or any other language. I'd be having to do this exact same type of profiling. So I'm not just doing this because it's Python. This is like identical to the profiling work I'd be doing in anything else, just with additional tools. So this is, when you think of it that way, not too bad on the workflow. We rebuild. I'm expecting 50,000, maybe 50,000 steps per second. We'll run mobaperf, and we will copy this over to the Docker again. And now we can see that these are pure C. These are pure C functions. Ooh, that was way more than I expected. 67,000 steps per second without that profile overhead. There's still a few functions that you can tell have a lot of overhead, like these are huge call amounts. But now we get to look at these functions individually. So did this just shift? Hold on. Oh, that's really major. Look, So before, step was at 3.6 seconds, and it was twice the amount of time as creep AI, right? And scan AoE. So I'd say, hey, look, we're losing most of the perf in step. But actually, when you take out these crappy little functions that are just triggering call overhead, because step here is triggering profile overhead every single time it calls one of these functions, update status, update cooldown, which is every single entity in the game. When you take this out of the overhead, the step function actually looks way better, right? It's only 2 seconds. And scan AoE is pretty much the same amount of time. And the neutral AI is also a big chunk of time. And it's actually even now with the creep AI. The creep AI is even a little bit slower. So I think we continue on this. We're going to optimize the little functions. And then we're going to take them out of profile until we figure out like the relative assignment of how expensive the big functions are. And then we're going to figure out, once we no longer have anything left to optimize on just like the C side, then we're going to think about like caching, targeting, and stuff like that. And we're probably only going to have to make 2 or 3 changes to this whole code base in order to, like, from the whole start until now, there are going to be like 2 or 3 high-level changes that we have to make to take this thing from 70,000 steps per second to 1,000,000 steps per second. It's really that easy. And the difference between 70,000 and 1,000,000, let me put this into perspective. If you want to get 1,000,000 steps per second train, and your environment runs at 1,000,000 steps per second, you just need to run 2 of those environments and like call them back and forth. So when one is generating data for you, the other one is ready, and you just go back and forth. Very easy. If you have a 70,000 step per second environment, you need like 20 cores, and they have to be very, very tightly and accurately relaying information across all the process boundaries. Otherwise, you lose too much of it and you won't get 1,000,000 steps per second. So it's so much easier when your environment is just fast by default. I see we've got a lot of folks on YouTube, so welcome. All of this stuff is open source. This is all available in Pufferlib, which is the main project I work on. It's on github.com, pufferai/pufferlib. Currently, we are on the ini-config branch. It's going to be merged into dev soon. It's in environment/ocean. You can play around with it there. If you like my work, please star the repo. Helps me out a whole ton. /end-add. Okay. Function to start with next. I think compute observation is actually looking pretty good now. I'm pretty happy with that. Yeah. Let's go to nearest scan target. I think this is the first place. Nearest scan target. Okay, so L2 distance is calling back to Python. That's really bad. That's like a straight up error on my part. Why is it calling back to... Why is L2 distance calling back to Python? It doesn't look like it should. It's a float that takes in a bunch of floats and returns a float. Huh? Wait, why is this highlighted? Pi error occurred. Huh? It's injecting some sort of error check here. Pi error occurred. Is there a division thing? Compiler thinks that this function can throw an error, and it's not being caught by my current error checks. I have all these flags at the top saying we're using C division. We're not doing bounds checking, initialize check. We're not doing any of that. Isn't squared also slow? Power function is slow, right? Is there a better square root function as well that we can use in C? Where's the C square root function? Okay. There is just a built-in square root. Is there a float version of it? C float square root standard library. Square root F. Okay, so we need to import this. And then we need to implement... we need to just change a couple small things. So this L2, and I think we should just do cdef. So float dx is going to be x1 minus x2. And then we're going to return square root like this. And then we need to do... Yeah. And this should be square root f, isn't it? Because they're floats. Is there a faster... There's not like a fast L2 in C standard library. No, C standard library is small. So I think that this is what we want. Let's try this out. Let's see if this does anything for us. This is the type of optimization you have to do for this, though. So let's go get the new file. We should have a new function. Distance. Okay, we have a new distance function, right? This nearest scanned went down. I can see that this went down. It is still saying that there is a error check on this, though. So now the code is different. Let's see. So we went up from 67 to 69,000 steps per second. This is with profiling overhead. It's like 200,000 without profiling overhead. And then it'll be like 400,000 to 500,000 on the actual machine that we'll be using for training. So we're like a factor of 2, maybe 2.5 off still. This function here is step. Oh. Yeah, so we have very little Python overhead. This is fine. Nearest scan target is down to 0.15 with a ton of calls. So this is mostly call overhead, actually, which it should be. Nearest scan target should be very fast. And actually, I think that most of this overhead is coming from this right here. Well, this is bizarre, though. Like, this is something I don't understand, and I want to learn right now. Somehow this function can potentially throw an error. Is this something with how square root is implemented? Can square root f throw an error? I don't know why it would throw a pi error. That's bizarre. Let's look at this code. This is what it compiles to. I don't know if anybody watching has any idea. You can go ahead and let me know. I have no idea. So these are just like automatically generated variable names. Obviously, they're garbage. This is the L2 function that we defined. You can see it has a bunch of garbage, but it has our distance function. This is right here. This is the pointer dereference, right? Neutral y, neutral x, target y, target x. And then we get if unlikely. We can actually just read this out, right? If unlikely, the output of this function, pi xt underscore 3, is equal to -1 and pi error occurred. So if this function returns -1, that's the C error code. What's this pi error occurred, though? Pi error, pxl1. Hey, everybody's been saying ChatGPT is gonna solve everything, right? ChatGPT is gonna solve everything and take all the jobs. Let's see if it solves anything. I do this every so often, and it's got its ChatGPT currently has a success rate of like 0. We'll use 4. What's better, 4 or 4.0? I think 4 is better, right? 4.0 is worse. Here is the what is it? Compiled. Four is greater than 4.0 for programming things. Okay. Well, we're gonna try it. We're gonna see. I bet it's gonna fail utterly, and we're gonna feel stupid. But whatever. I would if it does. Hey, look, if it actually solves it, then I get to move on with my life, right? Because we don't have to stare at this error any longer. This. So I'm giving it full context for everything here, right? Handling of floating point arithmetic. Okay, that's what I was guessing, right? But like, why? Okay, I guess there's an error check against. That's a kind of decent response. Python do not set Python exceptions. Yeah. I say it's kind of a mid response. This is kind of a mediocre response, right? Like, I was equally confused why it's raising a pi error instead of just having the error be in C, given that I used a C function call. But like, this is a squared number. Like, this cannot be negative, right? Why is it inserting this stupid check? Like, the compiler's not smart enough to figure out that this is always positive, I guess, right? Do we need it to be square rooted? I mean, we don't necessarily need it to be square rooted, but it is mildly inconvenient, right? Because then we have to work in like L2 squared space. We could do L1 distance. That would actually be faster, right? Maybe we just do L1 distance instead. Hey, lots of people on the YouTube stream. Welcome. This is all open source. You're free to come and try it out. The latest version of the demo right now that we're optimizing is right here. Perhaps you saw this on Twitter. So we have the agents playing... Well, we have the scripted agents playing full games. We're just reusing the creep AI for heroes with fixed lane assignments. The goal for today is to make this thing, like the title says, 1,000,000 FPS. I'm confident that we'll get it today. We're only a factor of 2 off. We started at like... I guess we started at 150k, and now we're at like 500k equivalent. So we only need like another factor of 2 and we'll be there. And then after that, if we have time today, which we should have plenty of, we're going to start on the network architectures for this stuff. And that's going to be the tricky part because the network also needs to run 1,000,000 steps per second, which is crazy talk for reinforcement learning, but we've done it before. So maybe. I'm going to add a comment on here for now that says square root throws possible error, which calls back to Python. Maybe some way to avoid negative square root check, or just use L1. And L1 looks like a diamond, which is kind of a fine shape. I don't think that'll make too much of a difference if we use L1 versus L2. And L1 is faster to compute. It should be, right? Yeah, absolute value should be way faster. Well, this is such a stupid completion, right? There's no reason to cache like that. All right. We're just going to replace L2 with L1. We only use this in a few places, I think. 2. There we go. Rebuild. And we will see... While we're running the profile on this, I'm going to see if the HTML, the annotations look better. If we're still calling back to Python by doing this. Let's check this out. So we have our L1 distance. Perfect. And now if I look for L1 dist, it's still calling back to Python. Really? Pi error occurred. How? Is it just anything that returns a float it's assuming is an error code? There's actually nowhere in the math that this can throw like a divide by 0, right? So this doesn't make a appreciable performance difference as far as I can tell. And it's not avoiding the call back to Python. Let me think. No, abs is defined for anything. Is this like overflow or underflow or something? This is fab f abs f go to pi xl0. Huh? It's really weird. Oh, wait, wasn't this clip doing this before as well? Maybe there's a C flag that I'm missing, like a Python profile flag. Is there one of these that I'm not thinking of here? Python flags. Where is it? Is there a list of them? Sources. I don't know. That's a bit weird. I think this is going to get to be rather boring rather quickly if I don't... Let me think. Inline, does inline solve this? Do I have it inlined already? Let me think of like a quick workaround for now, so we can get back to the other stuff. I think it's because it's in a function somehow, right? I'm going to try one last thing, and then we're going to move on, and I will sort this off stream. We'll like just do other stuff for now. I want to just see if I inline it. It like... This math should not be triggering an error, so I think it's something about it being a function call. Like, I think it's somehow interpreting this as an error code, like, because it returns a number, and C uses error code. Like, C, usually, if you return -1, it's because there's an error or something weird. Like, I think that there's something like that going on. What if I just inline it, right? Inline float L1. Literally no way that this should be erroring now. Okay. Inline float L1. And it's still throwing the stupid error. Okay, so and it's compiling to call this function as well. It hasn't compiled with the inline, which is even weirder. Okay, so I will figure this particular one out later. That's on the to-do list. We'll go back to L2 distance for now, just to keep the gameplay consistent. We'll just do L2, 2. Oh, by the way, that makes ChatGPT even more wrong than we originally thought. So I think that that's not going to be replacing anything anytime soon. Okay, next thing from profiling, right? New profile run. Probably need to rebuild it. And then we will run the profiler and we'll go on to the next potential candidate function. Factoring in that there is call overhead for this specific function. We're going to have to estimate the overhead since we didn't solve this, right? That's kind of gross. We could always just inline it ourselves. For the time being, I might just do that. Okay, so here's the latest performance number here. We have scan nearest target here. This really isn't that bad. This is a big number of calls, and it's doing L2 functions, and it's only 0.15. Okay, so compute observations is 1/4 of a second. This is a big expensive call. So anything that's more than this should be justifying its cost. This here has, I think a lot of this is just call overhead. But this move to function does do some stuff. Let me see. Move to, move to, move to. Here's the function def. So we do some casts. We do some checks on the grid. We do some kind of gross conditionals here, but like these should be fast. They're gross, but they're very fast. These are just comparing a few things to constants. And then we move some stuff around in memory on a grid. So there's no hard math here. This function should be very fast. And because this function should be very fast, we're going to take it out of the profile. Where essentially when we're taking stuff out of the profile, we're saying that like, hey, we know that this is fast. Or we know that this is maybe not fast, but we know that this is as fast as it can be. So we don't need to get the call overhead of this function in our profile. And actually, I just thought of something that we can do for now. What we can do is we can take this L1 distance implementation, and we can do if abs. We can just do it like this. So we have this is L1, right? If we just implement it manually, it shouldn't be able to call back. So we'll just do like elif abs neutral x to distance. And then we won't have the call overhead from this anymore. So this is a nice workaround for now, is just hard coding it until we can figure out, off stream when it's not as boring. We can figure out the distance functions. Okay, perfect. So now we build this. We should actually have some substantial changes to the HTML, hopefully. If we still have errors in here, it means that there's some low-level math shenanigans going on that I do not understand. That's the only explanation for it. Let's run the test while we look at this. Okay, perfect. So it's something about the call, the function call, because this runs pure C. Oh, and perfect. Just like that, we went from 68,000 to 78,000 steps per second. And this is, again, this is with the profiling overhead, which is a lot. So we're making a lot of progress here. Let's see now what is saying, what did we say has overhead still. So this compute observations, I see a very low number of calls and a substantial footprint, but this makes sense. The compute observation function is actually doing real work. So I'm actually pretty happy with, what is it, quarter second or whatever. That's a perfectly valid thing. This is doing a bunch of loops. This would be horribly slow in Python. And nearest scan target is still 0.181. That's a little weird. Let's go look at that function. I guess does it get called a lot? Oh yeah, this gets called a lot. Yeah. So this is performance critical then because it gets called a lot. Is there anything we can change with this, or are we going to say that this is mostly call overhead? This 200 is hard-coded. Let me explain this function, because this is actually a kind of cool piece of tech that I built. So there's a scan function. We have a single allocated buffer for the whole program that gets reused repeatedly. And the pattern is that you scan the nearby area in the game for other enemies, targets, whatever you want. The scan function is very versatile, and it fills up this buffer with targets. And then you don't have to do a double loop over your nearby locations. After that, you just go through all the targets that the scan function found, and you get the target or you filter it, whatever, depending on which ones you want. And the logic is very clean for that. So here, to get the nearest one, you filtered the first time, you went through all the targets, and now all you're going to do is you're going to compute the distance between the player and the target for each of these, right? I see one very small optimization that we can make here. Only one that saves us 2 pointer dereferences. Let me see if there's anything else that I see. I think this is going to be pretty negligible, but we'll do it anyways just to show you. You allocate the target here. If it's null, we are done. If nearest target is null, then nearest target equals target. Continue. We can also avoid this check by just setting nearest distance to be something big. Okay, there are a couple little optimizations we can make here. Because I think we're going to use this function even more than we're using it now. So it's worth taking a second to make a couple quick changes to this. So here for nearest scan target, we're going to say nearest distance equals 9999999. Big number. Now we no longer need to do this, because any distance will be better than this nearest distance. So we save ourselves potentially 200 checks like this. And we also get to do, we'll do float player Y and player X. So now, instead of doing this pointer target here, we have these variables already, right? We get to reuse them. Then nearest target is equal to target, and nearest dist is equal to dist. These are pointers, so this is fast. IDX, distance, yep, this is all what we want. Perfect. Was it 0.181 before? I think this is going to be a pretty negligible optimization, but we did it anyways. We've got some much heavier optimizations coming up. Every little bit helps. We'll run this perf test. Grab our latest HTML. We can see here that this is substantially shorter now. Actually, that's not too bad. We went from 0.18 or whatever to 0.14. And given that this is actually like close to the amount of overhead that I would expect, like we probably made this like twice as fast or something, because this is like this number here is not just the function time, it's also the function call overhead, and we called it a bunch of times. So that's actually probably a pretty decent little performance optimization. 92,000 steps per second. Of course, we have the same amount of overhead coming from the one Python call, which is kind of obnoxious. Where the heck is that even coming from, actually? That's super obnoxious. Oh, it's coming from this. Yeah. Yeah, that's gonna happen. The while loop. This tells you how slow Python is, though. Literally just this, just this while loop right here, which is optimized. You can see that I pre-computed the actions and stuff. This is still, substantial overhead. Python's so slow. So freaking slow. I still love you, Python, but you're slow. Okay, now compute observations has gone up, but this is just the relative time slice increasing because it's a fixed 10 seconds. I'm still very happy with 0.3 seconds for a function that's that expensive. Like, this does a lot under the hood. Now we get to look at, we only really have 4 functions plus the step to look at here for optimization. This is where all the compute is going. Maybe basic attack, but with this number of calls, I don't think so. In fact, let me do that real quick, just because I want to be sure that we're getting every little ounce that we can get. Attack. Where is it? Bient. Basic. Yeah. Yeah, this is nothing. This is purely call overhead, right? So we don't need to profile this whatsoever. And then there's this attack function here, which... Is this attack function not more substantial? Is attack not in here anywhere? Where's attack? Oh, way down here, because it doesn't get called as much, right? So let's see. Yeah, basic attack gets called super often, but it gets called on when it's on cooldown or whatever, I guess. So then attack only gets called, much less often, so the call overhead is negligible. So let's add that real quick. Uh-oh, what happened? Basic attack or Bient basic. Okay, so we take the profiling off for this. Any of these already optimized functions where we're looking at just call overhead, good idea to to fix those up. This should bring us to about 100K, I think. Maybe 100,000 steps per second. On the profiled version, by the way, which is huge overhead. So even though we're reducing the overhead is still huge. The nice thing about these profile decorators is when we just turn profiling off globally, they don't interfere with anything, so we won't have to, get rid of them. And 93,000. I mean, I guess there's some variance in run to run. Did we get rid of basic attack overhead at least? We did. Okay, so this as type loses 0.1 seconds. We'll look at that later. I think this should already be the right type anyways. We'll say nearest scan target. Didn't we add a decorator to this? Wait, I thought we said that nearest scan target was... Oh no, we didn't exclude this yet. Yeah, we didn't exclude this yet. Let's exclude this as well. Because we already optimized it, so there's no point in timing it separately now. This is already about as fast as it can be. That saves us another 0.1 seconds out of this, so another percent on the perf test at least. Just a function call overhead. But it's not that we're this is kind of optimizing the benchmark, not optimizing the program right now, because we're removing function call overhead for the purpose of profiling, But the reason for this is because it gives us more and more accurate profile information, which then lets us actually optimize the things that matter. So like here, like this function, we didn't even notice it in the call time before, but now we can see, hey, look, it looks like there's actually substantial overhead being incurred by this move towards function. Let's see if there's anything that we can actually optimize there. And we're going to go up the stack this way. So we will move towards. This is move towards. We can see that we have this kind of gross condition here. We could put a table for this at some point. This one's tricky. This one's actually kind of tricky. This is definitely taking substantial time. And did we just take move 2? Yeah, so this is not including overhead from move 2. So now we know for sure, essentially, that this function is slower than it should be. These conditionals really shouldn't be that slow. Is it this rand right here? I was actually thinking of caching jitter. Is that crazy? I don't think that's crazy, right? To cache jitter. So you don't have to do random number manipulation. Do we even think it is the jitter, though? It shouldn't be having to jitter that often. It could be that the jitter's really slow, though, right? Random number call... RNG is not free. You know, you need some good RNG. We can figure that out very quickly before we invest too much time. So all we have to do is... we go like this, right? And let's see if this changes the overall timing of this function. It was 0.6 seconds before. So if this time plummets, then we know that we're using up all of the compute in the infrequent jitter operation, so the jitter is very slow. And then what I will do is I'll just pre-compute all the RNG for the whole program, which is not hard to do. That's a really nice trick for folks, by the way, is to pre-compute RNG. I do this even in Python sometimes. Interesting, so it got faster, but not by a huge amount. Oh, but wait. The number of calls went up. What do you do? To pre-compute RNG, or what's the question about? What do you do to compute RNG, or is this like a new stream question? It went from 6.4 at 0.6 seconds to 85 at 0.5 seconds. So I'd say there's a pretty substantial time save here. I don't see a follow-up to that question. I'm going to assume it was about the RNG. So I will just show you what I'm going to do for that. It's a very nice trick. It's a very, very nice trick, actually. You get to replace an expensive RNG call with a lookup. And do I want to make it one-dimensional or two? I think 1D is probably better. right? Yeah, we'll do 1D. So float array RNG, right? And then what we're going to do is int n. So we're going to do self.rngn equals. We want it to be a decent amount of RNG so that we have like some good diversity in here. 10k should be good. NumPy rand RNGN. And yeah, that's 0 to 1 RNG, right? I was just making sure I didn't have it confused with rand n. So this jitter right here is -1 to 1. So RNGN. So we're going to do 2 times -1. So we're going to pre-allocate. This is essentially pre-allocating Kate. Yeah, locate RNG -1 to 1. And now when we need this is pretty cool. Oh, we also forgot RNGN. We need int RNG IDX. So we need to keep track of where we are in the RNG. RNG IDX is going to be 0. Okay, and now when we go to rand, which is in jitter here, now we get to do something cool. So jitter you see how that works? Now, we do have to do an additional check, which is that it's equal to we have to do the modulo here. So this is a fast modulo. You see what we did? We replaced an expensive RNG call with a lookup into a table, but the table's very big. Now you have to be careful not to overflow it and a lot of other things, but it's not that complicated. And if you do it this way, we should get some speed out of this. We should get some speed. Expected float got double. Whoops. Me forgetting the API, of course. C mode. This is .as type. Did this stream crash or something? Why is... Oh no, my Super Maven was just lagging. That's fine. We're good. And let's see what this gets us to. This should be a legitimate speed optimization, not just a compiler or a profiling optimization. Shouldn't be huge, but it should be something. Huh. That didn't do very much. It is faster, but only marginally. Let's make sure we didn't screw up something with the Scython here. So jitter X, jitter Y. That's not super worth it. It's weird because it looked like before that this was where the slowness was coming from. And I've seen this type of thing be a huge boon before. Well, at least we know now that this is not where the slowness is coming from. Move 2 is a relatively fast function. We do have some additional checks and stuff here, and we have this series of checks and assignments. We also have this lookup. Maybe we'll figure this one out as we go through the other ones, because this is called by other functions. Let's look at the bigger ones for now, because I'm drawing a blank on that. So we have two very similar functions here, and then we have a function that they both use. So you see that this time here, this is cumulative time. So what this is saying is that scan AoE doesn't call anything else that is timed. It's like all the time is spent in scan AoE. But then creep AI here, there is like an additional second, pretty much a full second in each of these, a little more even, that is spent in other function calls. And I can tell you right now that the majority of this is spent in scan AoE. So basically what this is telling us now is that of the 9.5 seconds that we're spending in this code, we are spending about 6.3 or something. No, I did that wrong. More than 6 seconds. So more than, I'd say about 2/3 of the time of the whole simulation is being spent on neutral and creep AI. And this is why having to simulate enemy AI is evil, because it's really hard to do fast. We spent a whole bunch of time making sure that the pathfinding was fast, but there's still other stuff to optimize. So I think we're going to start with, they look to be about the same speed. Let's start with the creep AI. So this is what creep AI looks like. It's not calling back to Python. Let's see if we get a free win in the neutral AI. The neutral AI is also not calling back to Python. Okay, cool. So what this is telling us then is that because we're not profiling these move towards functions and stuff, the total time, including movement and such, outside of this scan AoE function is still quite substantial. And this is hard to optimize because this is just getting called a ton of times, right? This is getting called 5 million times. So this is running more than 1 million steps per second, but it's still going to hamstring us because there's so many of the creeps. And this is the thing that I was most worried about having to optimize as well. Because it's reliant on some harder to do optimizations. The easiest optimization for this is frankly just to run the AI less often and to cache stuff in here. But we're going to need a better breakdown of where time is being spent. I'm going to use the restroom real quick. I'll be back in 1 minute. And then if we can make the AI like a few times faster, we hit our 1,000,000 steps per second just based on that. So if we just cache something and compute AI stuff a little less often, we'll hit our 1,000,000 FPS just based on that. So I'll be right back, and then we're going to go do that. Okay. I should grab a drink, and then we'll be good. Okay. We're good for the next hour. I'll take a quick break in an hour to grab a shake, and then other than that, we are good until, I don't know, next 4 hours or whatever. So I don't know why I even had these headphones on. I don't need them. Okay, so right now the AI routine is every frame. It does an expensive scan operation where it looks in a nearby area and it looks for targets to go pathfind towards and aggress. If it finds one of these targets, then it checks if it finds one of these targets, then it looks for the nearest one. This is a relatively fast function. And if it's close enough, it will attack that target. Otherwise, it will path towards the target. If it doesn't find a target, then it does this pathfinding check. And it then moves towards a specific position. So the thing that's interesting about this to me is that almost none of this should ever be getting called. because the neutrals, the way that the AI is scripted at the moment, nothing plays with the neutrals. So let's see if that's true. According to this, the neutral AI spends 1.7 seconds just on itself, on this function, 2.7 seconds total. We can assume that the additional second is spent on scan AoE, which would line up very nicely with the other number. But 1.7 seconds is somehow being spent on this function. I can see that the attack function here, it's not called very often. So this attack function shouldn't be biasing it because we're calling attack in here. None of these other functions should be interfering. How the hell is it spending 1.7 seconds on these function calls? I mean, that's 3 times the compute of the move towards operation, which does everything else. Am I looking at this right? So neutral AI here, right? So the neutrals in this game, let me pull up the GIF. Do you see these green things that are like respawning every so often, but they're not moving otherwise? Those are the neutrals. They only move for the most part if you go get near them and interact with them, which is very rarely happening. Like you see every so often a green pixel will like get pulled in, but it's very rare with the way that the scripts run right now. And it should be relatively efficient. So what should be happening is it runs fine. It runs the scan AoE, which is slow, right? We expect this to be slow. We expect this to be very slow, actually. Found target's false. This is false, so nothing happens. This doesn't happen. But somehow, according to this, scan AoE, which happens every single time, is taking only 2.7 minus 1.7 is 1 second for this really expensive scan that goes through a whole bunch of tiles. And the rest of this code, which should be doing nothing, is taking 1.7 seconds. That's absurd. That is absurd. How much of this could be function call overhead? Not that much, right? Because this move towards function, which has some logic in it, is taking 0.6 seconds for almost the same number of calls. So basically, at least a full second of this total time here is legitimate. It's not just overhead, call overhead. What the heck would this possibly be? I wonder if it's these default args. I see pi error occurred in here. 1011. Okay, I'm getting a little bit suspicious here of these default args. It's possible that the parser is very slow for these. It's the only thing I can think of. That'd be a really funny low-level finding, wouldn't it? Only thing I can think of. So, beint scan AoE. Make sure we call it in the right order. Neutral AI. Neutral. Where's the stupid thing? Beint new. Void. Here's our signature. So we can do neutral vision, true, false, Friendly, hostile, creeps, towers. Okay, this is fine. I'm gonna try something first, which is just found target equals false. And in principle, this shouldn't mean that you spend less time in the spawn functions, right? It should only mean that you spend less time in the other functions. I realized I did this in totally the wrong place, so I screwed that up. Let me put it over here. It should be not in scan AoE, it should be in neutral AI. Right up here. Oh no, wait, what? Yeah, this goes away. Yeah, I have this as just as a hint to myself. Okay, perfect. So, yeah, what happens if we do this? This will be interesting no matter what it tells us. There's a bunch of performance just going into the ether here, and we're gonna get it back. Interesting. So the creep AI is now 2.6 second total time. Creep AI time has gone up, which makes sense because proportionally it has a bigger time slice available. Neutral AI was 1.7 second total time, 2.7 cumulative. And it went down all the way to 0.7 second cumulative total, and obviously cumulative. Wait, did I do that right? No, right here, basically same thing. It moved towards went up a little bit. So what this means is that it's something about the found target true path or about the call to the function itself. So that's some really nice little archaeology to do there. Now what we're going to do is the more aggressive version of this. We're going to do, which is, we're going to call the function, but we're going to call it without these default args like this. We're going to call it with raw bools, and we're going to see what happens if we do that. I did see some things on online about default args being wonk, but it didn't show up in the HTML, which is weird. Didn't show up in the HTML. Let's see. I give this 50-50 chance that we get something interesting out of this. And if this works, this one optimization will basically be enough to save us. Maybe we'll a little on the scan AoE. Okay, interestingly, this went right back up to where this was before. Went right back up to where it was before. Okay, next test. Maybe there's just like a very slow computational branch, right? Maybe that branch is just really slow. So we'll do found target is here. We scan for it. We determine that these args are actually parsed fine. We'll set it to false afterwards. Let's make it take the other branch that we know is good, right? Now, if we make it take the other branch like this, then what do we get? Okay, it's about the same. So that's kind of bizarro. Let me just put into words what this means. So if we set this function to just be nulled out, right? Then it not only says that you're not spending a second calling the function, which is obvious, but it also says that you save a second of execution off of the rest of your function, excluding that. So somehow I think that the call itself is slow. It shouldn't be a whole second of overhead slow. That's ridiculous. What's unique about this function? Beints aren't slow, are they? Maybe we open up the HTML again. Right here, right? So, entity star neutral. This is a constant. Entity star, or found target. Wait, what? Pi t struct vtable. Oh, this is just a class method. This is fine. So this is essentially self. This whole giant thing is self. This is self dot. Scan AOE is our function. Self neutral. This is a constant. And you can see it compiles here to reasonable args. What the heck is this? If unlikely pi error occurred. Not everything has these things, right? Oh no, wait, this does still have it. If unlikely pi error occurred. Well, that's just function call. Very weird. Well, we absolutely need to figure this out. This is like the main blocker right now. Right? The main blocker. Oh, I have an idea. I have a cool idea. Let's just eliminate any chance that this is just some weird Python bullshit. Because, you know, it's happened. Let's do neutral AI. Instead of making this thing false here, let's go back to the original call, right? But then what we're going to do is we're going to make scan AOE just return false. All right, right here. Return false. And that will immediately tell us if the profiler is just screwy or something's going weird or what. Because weirder things have happened. Okay, so that's interesting. The neutral AI here is actually still slow. It's actually still slow. It's got 6 million function calls and 1.4 seconds. Versus, since this gave us the reasonable result, I'm going to compare this to not the function call, right? Which is right here. And we're just going to do found target is equal to false, right? So from 1.4 to 0.4. Is this actually the amount of overhead that's being added by the function call? I don't want to be wasting my time if I'm just profiling function call overhead, but it seems like it's an abnormal amount of function call overhead. Let me look at, you know what I should do? So this doesn't come up as having overhead here. What I want to do is I want to go look at the scan AOE function. So it's got a big signature. It's got the trace back here. Okay. So, new hypothesis, right? Maybe because this thing takes a bunch of arguments and stuff, the function call overhead for this is just especially bad. If that's what we think is happening here, the next best thing we can do is we can eliminate the function call overhead and see if there's still something weird. So scan AOE. We know it now returns, oops. Where is it? So we're going to call it from here. We're not going to just set it to false. Where is it? Bient scan AOE. Okay, and we're gonna add the decorator to it. Now, we can't keep this decorator here because this function we also need to optimize. This is probably the single most performance critical function in the code base. I've saved the best for last, which is the opposite of how you're supposed to do profiling, but you know, whatever. I just want to see if like the whole thing gets to be way faster just by cutting out these function calls. And we're cutting out the Python overhead to the function calls, not the function calls themselves. $133,000 steps per second. Yeah, that's substantially faster. So there's definitely something about the overhead itself. So now we know, okay, 0.7 seconds, right? 0.7 seconds is what we're taking for 9.6 million. 9.6 million calls. And now what we're going to do is we're going to look at, whoops, getting there. We're going to give it the full function, but with no signature. So we're not going to be able to see the breakdown, but we're going to get accurate profiling, where we're not just profiling expensive function call overhead. The main annoyance with profiling this stuff. Okay? Okay, so this is substantially better, actually. The proportion of time has decreased quite a bit. There was essentially a whole second of overhead being added to think to both functions maybe, just from the call signature itself. So let's see from here. So the creep AI, it sticks out to me that the creep AI is substantially slower than the neutral AI. There are fewer creeps than neutrals. They're both calling scan AoE once per frame. And the fact that the creep AI is still that much slower means that the other pathing stuff is substantial. That move towards, especially right there, needs to be optimized a bit. Well, maybe. 2.9. Have you done much with Unity AI agents? No, I've done stuff with Unity though, and I've done stuff with AI in Unity into AI in AI, but not with their ML agents API. Here, I'll show you the format that I advocate for. Not advocate, but the format I suggest rather. If you want to do stuff like that. The thing you want out of Unity is usually a nice front end for RL. You can do that like this. Here's a Unity front end for Neural MMO I wrote. The game environment is not written in Unity. The game environment is written in whatever else you want. You just do a WebSocket server or whatever that will then send all of the data packets required to render to Unity, and then you use Unity just for rendering purposes. So you strongly decouple the simulator from the Unity engine. Otherwise, like, if we want to talk about speed for things, well, I guess it depends on how you're implementing stuff, but most of the time Unity is just going to be like the slowest possible thing imaginable for simulators. Technically, it's possible to write fast simulators in Unity, but if you're just like writing stuff like you do normal game dev in Unity, you're going to be about 1,000 times too slow to be useful. If you write efficient state simulations in Unity with headless, so you decouple the rendering, then it's possible, but you still have to go through their API. So you have to get the data into Python, and that's hard to do efficiently. If you do it with, I think what their default is, you're losing, again, like more than 99% of your performance immediately. Next step here is going to be to remove move towards from the profile, just so we get an absolute. We need to know for sure that we're not measuring function call overhead. And then this will give us like the final actual performance overhead of everything. Yeah. This should give us like everything that we need from this. Build ext. Compute observations. Okay, this is taking up a bigger slice of time, which is actually probably good because this means that other overhead is lower. We now have, what's this, 13 million in 1.7 seconds creep AI versus before we had 10 million in about the same. So like 30% of this was just function call overhead, it looks like. And now we actually get like a good picture of what stuff is taking what amount of time. So optimization on movement function, optimization on scan function, and caching is what we get to, which is what I expected that we would get to today. But we've basically confirmed that at this point, there's nothing else that I've really majorly screwed up. The design of everything is pretty solid. And the only thing that we're really missing is a few optimizations maybe on movement and scanning, and then caching. That's about all. Take a quick 30 seconds to clear my head here, and then we're gonna ramp up for this last little push before I take a 5 minutes to make lunch. But we're gonna do this first. We're gonna get our efficiency, and then the hope is that after lunch I can come back and do the reinforcement learning side of things. We're already at, by the way, here we're at 189,000 steps per second with some profiling overhead. This is what we had before with no profiling overhead, so we're probably doing pretty well. And then the caching thing is what's really going to make this this thing pop. A few things for viewers at the moment. Again, it's all open source. I say this once every so often. It's all in Pufferlib right here. It's in the ini config branch. It'll be merged into dev soon. It's in Pufferlib Environments Ocean. You can play with it. Everything that you see today will be merged up by the end of the stream. If you like my work, please start Pufferlib. Helps me out a whole bunch. I also post all this stuff online on Twitter. It's strictly for AI stuff. So that's here. And yeah, you can see it's all like demos of code and stuff. Okay. Let's go back to the optimization stream now. Oops. So I want to look at the code for this here. Because we have some functions that we can potentially get a little bit more juice out of before we start caching. Are you currently working on Pufferlib full-time? Yep, absolutely. At least full-time, you could say. So definitely the exposure to stuff helps a ton. I'm really trying my best here to fix all the things that are cursed in reinforcement learning. And part of that is the simulation stuff you see that I've been streaming lately. I've got stuff with hyperparam tuning. I've got stuff with like widespread environment compatibility with Pufferlib. I've got super fast CPU vectorization, and it's moving crazy fast as well. The progress in the last 2 months has been nuts. It's all free and open source as well. This function is fine. Here's the big one right here. So what this function does, this function goes through all of the tiles nearby in a radius. It looks for entities on those tiles, and then it filters them according to any specific criteria that you specify. So you can specify, all these different criteria. And based on that, you can filter. Let me think if I like this or not. Is there a chance we see carbs supported with Wannabe sweeps from Wannabe correct directly? So let me tell you what happened with that. I posted all the stuff I'd been doing. I added Wannabe and Imbue a bunch on Twitter. I got like 4 DMs from Wannabe people wanting to integrate it. We sent some emails back and forth, and then they stopped responding, which was like weird because it looked like we were gonna set up some meetings. And then I got a DM from another guy at Wannabe saying that like something weird happened and like our emails just never went through to each other or something because they thought that I'd ghosted 2 meetings with them that I'd never set up. So somehow some wires got crossed and we didn't end up setting up any meetings. I should revisit that, but I'll tell you what I did do. I sent them a very nice doc. So I sent them, pro bono, I sent them this like thing for general improvements with sweeps that would help, as well as a guide on carbs integration for what they would need to add at native, and I linked the current integration with Puffer, which the current Puffer integration is not bad. So that's the current state of things. Carbs is awesome. I hope that they do it. Be a really smart thing for them to do. Let me think about the design of this function a little bit more. How many times do I use this? Scan AoE. I use it in player AoE attack, AoE push, tower AI, neutral AI, creep AI. Okay, so I see why I did this. I used this 5 separate times, and otherwise I would have had to have written out like 5 separate 2D loops like this, right? Little obnoxious though, because like it does require you go 2 passes over the data, doesn't it? It kind of does require you to do 2 passes over the data. There are actually a couple things I don't like about this. I don't like that you have this giant list of filter options in here. I don't like that you have to check every single filter option, even the ones you're not using. These checks actually matter. This is the most called piece of code in the entire project. So like even every if statement matters here. I know that if I were to write out all the code for this, if I were to just like time these loops, like mess with the indexing a little bit, make sure that was optimal, and then just copy paste the loop structure into every place I'm using scan AoE right now, it would work at the price of being gross and adding like another 100 lines of code to the project. This function might be one of those things that I thought was smart but ended up being dumb. If you think about it, it's like, it's really not acceptable to be doing a second pass over your data, right? Like to be computing, applying all of these filters and doing a second pass over your data. This is a go slow to go fast moment. I need to really think about this. This is a big thing with the project. This is the single most performance critical thing with the whole project, and actually with most projects of this type. There's actually more to it than just this as well, isn't there? Hmm. Let me explain what's going on in my head here, because there's a lot that's not apparent just from this piece of code and how complicated some of the stuff is here. So this is a representation decision. This is a decision about how we represent, fundamentally, how we represent and access data in the simulator. The way that I have it right now, everything under the hood gets discretized onto a grid. So you have a continuous position, but you also have a position variant that's discretized to a grid. And only one thing can occupy any grid cell at any one time. So what that means is that you have a very fast way of checking for entities nearby you. Whether you want to attack them, whether you want to do collision checks, anything like that, very easy. Because you can just check nearby grid cells, which is what this is doing, and you can go through the agents that you find there. The place where this scales very poorly is with larger distance ranges. So the way that I have this right now, the farthest that anything is seeing in the game is 5 squares. It's like 5 player lengths. It's very short. And trying to make it larger than that is quadratically bad. Quadratically bad. Very bad. The problem, though, is that the alternative is also hard. Because the alternative is that you have to go through all of the entities in the game. Which I have them. I have them in a nice big data struct. I could iterate through them. But there are like 200 of them, I believe. And mind you, you always have to do distance checks as well if you do it this way. Because if you do it that way, right, you don't get the benefit of saying, I know that everything that I just found is within a square. So you always have to do distance checks. Let me see precisely how many entities it is. Actually, this is in the Python. Okay, so we have slightly over 200. I have a buffer of 100 creeps that will probably need to be increased. We could say it's like 256 or something to be cheeky. Will be the maximum number. If I did it that way, all of the targeting would be directly on agents. I wouldn't have to do any index calculations. Those are cheap anyways, though. I wouldn't really have to look up player IDs either, because I'd just be directly iterating over the grid. I mean, over the entity list. But I don't think I could do it naively. I also think I still probably wouldn't use a function like this to scan them. Because if I use a function like this to scan them, you still have to go over them twice, right? Also, getting like the nearest K or whatever is really hard when you do it this way. Because like if I were to I can just change the loop order essentially to iterate outwards. If I wanted to do an approximate like nearest elements want thing, I could do that. But I would lose that if I did entity-based traversal. Now, there are data structures to help you with this, right? There are like quad trees and stuff, which can make this from an O of n to an O of log n process, which is way better on paper, but the constant factor matters a lot. And updating that data structure matters a lot, how fast you update it and such. C quad tree. 22 lines of code. Yeah, this is how you would do it efficiently. Where's all the code? Where's your 22 lines of code? Leaf nodes contain multiple points. Ugh. Recursive thing. I don't like this one. This is like a big difference though with the way that I represent things. Well, I think regardless, you still need to maintain a grid, right? Regardless, you still need to maintain a grid. This is worth spending a little bit more time on than I intended to today. Even if it means I only get a little bit of RL in at the end, because this is where you really make or break the perf of the game. And this is actually something that's been holding back, like, this is the thing that holds back, like, entire classes of simulators at the moment, is entity parsing of this variety. So, yeah, it's a big deal. The thing is, like, the algorithmic complexity of this is not trivial. Like, conceptually, a quad tree is not that complicated of a data structure. It's just you recursively partition space up. You just recursively partition space up so that you're not computing stuff over a ton of entities. Now, I don't actually need to do that, right? Like, I don't need recursive partitioning. Well, it's not about it being recursive. I don't need infinite partitioning. How many times do I need to cut up the grid? If I have 128 by 128 grid, right? Then if I cut it once, I have 64, 32, 16. Eight. That's probably good enough. 4 layers. And the reason I say that 4 layers is because what you would do is you would go through all of the entities that are in your 8x8 and all neighboring 8x8s and then do distance checks on them. So essentially you're doing 24 by 24 tile chunks is the way that you would do this efficiently. How many entities are going to be in 24 tile chunks? No more than 50, right? On average? 10? 15? How many checks do you have to do for this? Depends how it's implemented, right? What's the struct for the leaf node?